chapter, but we're not going to do the test before fall break. But that's right. You got to remember this forever. So at least we'll make it easy. So today we're going to talk about something called implicit differentiation. And really, we're just still working on how to differentiate everything, and we're getting there. We're getting close to being able to differentiate everything. So most functions, the book says, are called explicit functions, which means that it's really easy to solve for y, right? So like normally we have y equals something in terms of x, and we can solve it. But sometimes they're not that easy to solve for y. So like this one would be easy to solve for y. But think about if you had something like x squared plus y squared this worked last week. Let's see if this helps. Minus 7, nope, now it's an answer. 7x, 7y, 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 y, I'll just keep both in here, plus 3xy equals 4. That would be really hard to get y by itself. So we can't say, well, I just guess we can't take the derivative, right? That's what you want to say. But instead, we can do implicit differentiation, which just means you have to make sure you take the derivative with respect to x, which means if you take the derivative of something with x in it, you do the same thing we've always done. So I said, oops, I gotta change back to this. Proceed as usual. But if you have something that you now have to take the derivative of y, you have to make sure that you do it with respect to x. So that means, they say use the chain rule. I don't really know how I feel about that as the explanation. But basically, anytime you take the derivative of y, you have to multiply by dy over dx, because that's like the derivative of y with respect to x. And we'll do one in a minute, and I'll show you why we don't do the derivative of x with respect to x. Okay? So it says, find dy dx by implicit differentiation. On the AP test, it's not going to say, do this with implicit differentiation. It's going to say, do the derivative. And you have to recognize, oh, I have to take the derivative of y, so I'm going to have to do implicit. All right, so we're just going to go through and take the derivative of each part, because this is not product rule or quotient rule or even chain rule here. So the derivative of x squared would be and then, what do you think the derivative of minus y squared would be? Just minus 2y. But, because we're doing this with respect to x, whenever you take the derivative of y, you have to multiply by dy over dx, because that's like the derivative of y with respect to x. So think about if we did that for the x. If we took the derivative of x, and then we multiplied by the derivative of x with respect to x, you see why we don't need to put that in there? Because that's just 1. And so that's why you don't have to do that with x, but you have to do it with y. And then, what's the derivative of 16? 0. Oh my gosh. Have I mentioned how much I hate this word? And then we're trying to solve for dy dx. So after you take the derivative, you're just going to do the algebra. And we just want to get dy dx by itself, which in this case isn't so hard to do. I'm just going to subtract the 2x over. So that would give me negative 2x. And then I'm going to divide by negative 2y. And I'm going to get that dy over dx equals x over y. Because the negative 2's cancel out. So we're still taking derivatives. The only difference is now that we're taking the derivative of y, and then we also have to solve back for dy dx. How do you feel about that? Because the derivative equals x over y. So also notice, normally our derivatives only have x in them, so we only need an x value to find the slope. But if they asked me to find the slope of this, I would need both the x and the y value, and I'd have to plug both of them in. Which means most of the time, not always, but most of the time our implicit functions are not functions. Like they don't pass the vertical line test, that's why they have both x's and y's in them. So they're circles and hyperbolas and all those fun conic sections that we did last year. Okay, so how can this get more exciting? We could throw in the product rule, the chain rule, the quotient rule in the midst of all this, right? So look at, okay. Look, I gave you guidelines. So I said differentiate both sides with respect to x. That's what we just did. And then you're going to collect all terms with dy dx on one side and move all the others to the other side. That's just the algebra of solving for dy dx. We'll do one of these in a minute, doing all these steps. And then if you're trying to solve for dy dx and there's more than one term with it, you're going to want to factor it out and then solve for it. And then tomorrow we get to find the second implicit derivative, which gets really crazy, and there's always like one of those on the AP exam. I don't know if there's anything for you to write on that one. I think I just wrote something down. Number 4 we're not doing today, but we're doing number 4 tomorrow. So we'll just kind of hold on to that step for a minute. So I'm going to double page this here, and we could solve this one. A little bit more difficult than the last one because of this middle term right here, right? When you take the derivative of x times y, that's going to be the product rule. So you have to do the product rule, and remember when you take the derivative of y to put dy dx. So I'm going to give you a head start and see if you can get that first line started of taking the derivative. When you take the derivative of y, multiply by dy dx. I also follow this thing on Twitter called This Day in Math, and today it said This Day in Math. The metric system was adopted because they thought it was an appropriate day because it was 10-10, because the metric system is based on powers of 10. But then underneath that it said this is a lie because it was really adopted on 12-10, but it just looked better to say 10-10. So I don't know, I didn't retweet it because I felt like it was a lie. It sounded good that it was adopted on 10-10. And our whole little math team is on the metric system. The metric clock. I thought we could do that. Let's go, Kyler. I'll do the first part. 3x squared. No dy dx needed because it's just x. The middle part, first of all, you got to be really careful with this negative here. That negative, like I think of it as like a coefficient, so I'm just going to keep it with the x as I do this. Also remember, you only put dy dx when you take the derivative of y. So if I do the derivative of the first, that's just going to be 1 times y. So that would just become minus y. Are you with me on that? Oh, that's right there. But then, so I took the derivative of x and left y alone. So now I'm going to leave x alone. So that's going to stay negative x. And the derivative of y would be 1, but I also have to multiply by dy over dx. So it's like 1 times dy over dx. So that's the product rule there in the middle. And then plus the derivative of y squared is 2y, but I also have to multiply by dy. Oh my goodness. It's hard enough to teach math, and then it's extra hard to teach math when your smartboard breaks every 2 seconds. And then the part that always bothers me when I mess it up is that sometimes I just write 4 here for some reason, and then I miss the problem because I just left 4 there. But the derivative of 4 is really 0. Questions about this part? So that's the calculus part. Now comes the algebra part. You have to solve for dy dx, which means that's where my steps said. Everything without dy dx move to one side of the equation. Everything with dy dx keep on the same side of the equation because we want to try to factor it out and solve for it. I'm going to show extra steps this time, but usually I kind of do this all at once. So my first 2 terms do not have a dy dx, so I can just move those over. So that would leave me and so that would just change the sign, so I'd have negative 3x squared plus y. And normally, like I said, I just do it all at once. Like at the same step here, I would have factored out dy dx because I know that's what I'm trying to do. But in this one, I just went ahead and left it. And the reason I want them by themselves is because now I can factor out dy over dx. And I would be left with negative x plus 2y and then my last step is just to divide that over. So I'm not done until I solve for dy dx. So the derivative equals negative 3x squared plus y over negative x plus 2y. Questions on that? What? Oh. All right, so now that we did one with the product rule, you try this one, which it does say write the equation of the tangent line. So if you just get the derivative, then we can talk about what do we do. Same thing we've always done with writing an equation of a tangent line. This is another product rule question, only now it's on the other side. So take a minute and do the derivative and see what you get. Compare with your neighbor. I was going to say compare with your friends, but then you'd be like, so compare with your neighbor. Did Deborah ever answer why she's taking microdosing?
No, she didn't. I don't know why she has to, because she did get credit.
She should fight the fight.
I think she started crying and was like, you don't understand. I never answered.
Okay, I'm sorry. You don't understand. Where does she go to college?
Purdue.
Purdue wants to like get all the money they can out of you, so like unless you get a 5, and even when you get a 5, they try to convince you not to take the credit still. So, because the more classes you take, the more money they get. So interesting. Oh. While you're doing this, I don't think I ever put homework on here for Friday because the site was broken. I mean, for today. I'll check while you do your stuff. I'm gonna pause the video. I can't believe he just stopped saying that it's pledge. So we all stop. Wait. Doesn't he know how it's done everything? So easy to mess up signs. Here, I'll start mine up here. What? It's quiet. Do you agree with this derivative? Like, so that's the calculus. Then all the algebra comes in. This weekend we had a little campfire cookout, I don't even know, at my in-laws cabin, and then they wanted to talk about the new math, and it was just really a tough a really tough day for me. I tried really hard just to not say anything, but then they wanted my opinion. I was like, there's no new math! As nicely as I could, I said that. And then someone said, does it really help you later on in the other math classes? And I was like, so in calculus, there's a lot of algebra. So yes, algebra is important for calculus, because if you don't know how to do algebra, then you can't do calculus. But yeah, that was... Oh, goodness. So I'm going to subtract the 2x over. It's okay if you do it the other way, which means that sometimes your answers might be the exact opposite signs on the numerator and denominator. It just means you do the opposite way, right? So if I subtract this way, then I would subtract the 3x squared this way. So agree with me on that? Or maybe you wrote negative 3x squared plus 2y? Tell me if you disagree. So if I factor this out, I think that my derivative should be 2y minus 3 minus 3x squared over 3y squared minus 2x. And again, you just kind of check your signs, because you could have it like the negative 3x squared plus 2y, negative 2x plus 3y squared, or you really could have like a negative flipped and it looks like it's the exact opposite, but it really is the same thing if you have a negative switched on the top and the bottom. Which is again where multiple choice questions, you have to match your answer with theirs. The extra part of this says write the equation of the tangent line and the normal line at the indicated point. So again, just like we've always done, when they give you the point, you can plug it into your derivative. But the new part is normally we just have x in our derivative, but now we have to just plug in x and y. Really easy on this one because we're just plugging in 1, 1, but be really careful. It's really easy to plug x in for y or y in for x and then mess it up because of that. But since they're both 1, that's not too hard to do. So if I plug 1 in there, I would get 2 minus 3 over 3 minus 2. I want Mr. Schimpf to come in and evaluate me while this is happening and give me bonus points for keeping my composure during this. I don't think you can get bonus points, but I think the slope's -1. So again, just like we've been writing tangent lines since the beginning in here, if you have a point in the slope, you just write the tangent line. So y minus 1 equals -1 times x minus 1. And how do I write the normal line again? And what's the opposite reciprocal of -1? +1. So that one's just y minus 1 equals 1 times x minus 1. And again, the online homework's going to at least make you add that 1 over, I think. And it's usually solved for y already.
Why is it called the normal line?
I don't know. We should Google it. I'll Google it while you do this one. I had this as my check for understanding one day when Mr. Puckett was evaluating me, and I think none of the answers were right, so that was embarrassing. I think I fixed it, but... Here, I'm going to Google it while you do this. Why is a normal line called a normal line? Calculus. It's not going to say, it's just going to say how to do it. Is it because normal means perpendicular or something? Oh look, why is it called normal line? I'm always scared to click on these because sometimes they have inappropriate things. Normal, among other things, is another word for perpendicular. Yay me, I remembered.
Why is it called the perpendicular line then? That makes more sense.
Because normal means perpendicular. That's why. Alright, I'm gonna see if this actually works. Yeah, the answer's there. You got it, Kyler? What do you think? I think it would be. What do you guys think? Miranda says B.
Oh no. I also got negative 3y on the top, so that's one of the answers.
Oh, I wonder if you, because you're swapping everything the opposite way, I bet. So then you'd have, your sign on the bottom would be completely different, so then you'd have to match it up. Because you'd get 3y.
But take out a negative 4, right? That doesn't make sense.
Plus. Oh my gosh. This is supposed to be y. So I just said, oh, well, the 3y is going to stay on this side. And then if I move that over there, I would divide by it. So that would leave me 2y minus 3x on the bottom. That was me not showing any work to match that up. But I think B is the right answer. So did you have 3x minus 2y on the bottom?
Yeah.
So that would still match B, right?
Yeah, because I just got a negative one side, negative 3y on top.
Yeah. So you just have to be really careful about matching those up because they're tricky on multiple choice. Okay. So your homework is on Math Excel. Again, probably a good idea maybe to write some work out so that if you get stuck, so you can ask me for help. And then tomorrow, the hard part is we're going to talk about, now let's take the second derivative of this, which means if it's a quotient, then we have to do the quotient rule, and so that's tomorrow. And then the other part of tomorrow is they're like, hey, you can do derivatives with fractional exponents, which I think we've done already, but your book just now decided to talk about it. So that's the easy part of tomorrow. And then we'll do 3-8 this week, and then that's probably all we'll do. And then we'll come back after break and do 3-9, and then have a test. So we'll probably have a test that first week back in fall break, that last full week of October. So we'll end before fall break with derivatives of inverse trig functions.